This class is statistical analysis or IPADS statistics or advanced international agricultural statistics by Global Agricultural Sciences Department in University of Tokyo. My name is Takeshi Sato and we will use the discovering statistics using our textbook. This class is here and although this lecture is labeled as advanced, but we will cover the introductory method and this class covers introductory content. I will share the R code via Google Drive. I will share the textbook, lecture slide, and exercise dataset in Google Drive. Course materials are accessible only to students who registered this class via the Google form. And source folder is here, so please check. The object of this class is learning the basics of statistics and being able to handle the data and create graphs by R, and being able to run OLS regression, and if time allows, being able to do ANOVA. The next class is econometrics in November. The aim is understanding the basics of the causal inference. Statistics textbook is here, but we can use this textbook within this lecture, but some R code might be we cannot run some R code because some kind of package is out of date. So I will check the code and I will share the new operational R code via Google Drive. Grade is here. Submission is 100% of the assignment. And we will share Google Drive, so please check frequently. And next class is econometrics. Econometrics, we use this textbook, Causal Inference by Professor Scott Cunningham. Grade is attendance and presentation of the reading in turn. And this is free to read, so please check the textbook. Okay, so let's start the statistical class. First, chapter 1 is the quantitative analysis. The construction of chapter 1 is here. Firstly, we introduce the data and the observation. Type of data analysis is here. And there are quantitative analysis and qualitative analysis. Quantitative analysis, large proportion of biology, economics, and medical science, and so on. Such kind of research field use the quantitative analysis. The qualitative method is used in anthropology, history, sociology, and some of econometrics. Testing theories using language, articles, interviews, conversations, or media broadcast. In the quantitative methods, we test the theories using numbers or values. This is the difference, using language or using numbers. And we introduce quantitative methods in this lecture. If we want to write the thesis, master thesis or doctoral thesis, we required the research question and find something that needs explaining and test the concept. Observe the real world and read other research. Checking previous papers is very important because we need to find what is the something that needs explaining. Some kind of the findings are already observed or already explained by another research. In that case, that is not new, so we need to find the novel findings. We observe the real world and reading the previous papers. And then we correct the dataset to see whether your hunch or intuition is correct or not. We need to define and find variables. Anything that can be measured and can differ across entities or time. In reality, the measuring and identifying are the biggest challenges for us. Next is the explanation for variables. Firstly, we introduce the theory and hypothesis. Theory is a hypothesized general principle or set of principles. The hypothesis is a prediction from a theory. In this case, this textbook shows one hypothesis here. The number of people turning up for a Big Brother TV show audition that have personality disorder will be higher than the national average. National average is 1% in the population. This is the TV show Big Brother. And this is the statistical result. No disorder and disorder total selected by Big Brother TV show and rejected in the TV show is here. And we compare the disorder and no disorder ratio between selected and rejected. The first is the number of people turning up for an audition that have personality disorder will be higher than the general level in the population. General level is 1%, but the 11% of the contestant has the disorder. So the ratio is significantly different. Then the data would support the hypothesis. The contestant is the ratio of disorder within contestant is higher than the national average. 11% versus 1%. This is one example of hypothesis. This is very unique hypothesis, and I'm not sure about this TV show, but the originality is very important for the research. So this is a very interesting example. Next is the how to measure the variable. What to measure hypothesis. Another example is here. Coca-Cola kills sperm. This is also I'm not sure about this story, but this textbook shows the this hypothesis. Independent variables, and there is the independent variables, and also there is the dependent variable. Dependent variable is effect or outcome, and independent variable is cause or predictor. Then we can write this direction. Sorry. This direction. This is dependent variable is cause, and independent variable is cause, and dependent variable is outcome. So the direction is here. This direction is very important, and we cannot use opposite directions. So please check. And in this case, Coca-Cola is the independent variable. This is cause. And sperm is the dependent variable. This is the outcome. And in this case, fact, definitely not. So Coca-Cola do not have the effect on sperm existence. So you can drink the Coca-Cola or Pepsi or some other soda drinks. This is the result hypothesis and result. And independent variables, dependent variables relationship is very important. Next, I would like to introduce the levels of measurement. We can separate the categorize the many kind of variables, variables. For example, there is a categorical variable and continuous variables. Categorical variables include binary variable, nominal variable, ordinal variable. Binary variable means only two categories. For example, dead or alive. In this case, sperm is dead or sperm is alive. This is the categorical variable. Categorical variables and especially binary variable. And in other case, or rainy or not, there is only two categories. Then this is called binary. Nominal variables can include more than two categories. For example, vegetarian, vegan, or fruitarian. In the weather, sunny, cloudy, rainy, that is the nominal variable. And next is ordinal variable. Categories have a logical order, then that's called ordinal variables. For example, the grade A, B, C, D. You get grade A, B, C, D. There is more than two categories and the order has meaning. Then this is ordinal variables. If there is only two outcomes, fail or pass, then that is the binary variable. And next is the continuous variables. Continuous variables is constructed by interval variable and ratio variable. Interval variables, the we can check the example in this slide. Example is temperature, Celsius, degree. And ratio variables is weight, height, income, and length, and so on. So ratio variables, the scale must also, but the ratio of score on the scale must also make sense. In that case, that is the ratio variables. For example, 180 centimeter means twice as big as 90 centimeter. But in interval variable case, for example, 20 degree is not twice as high as the 10 degree. In that case, that is the not ratio variable. It is called interval variable. This is the description, and this is the level of measurement, and this is example. Numerical data with equal intervals between value, but no true 0 point. That is the interval variables. And there is a true 0 point, then that is a ratio variable. Weight, height, income has a 0, but temperature, absolute 0 is different from the 0 degree. The ordinal nominal, that is more the the difficult to calculate, because we cannot calculate the difference between colors of eyes. Blue, brown, green, we cannot add, or we cannot blue minus brown, such and so on. And ordinal is also a bit different from the interval or ratio variables. educational level, high school, bachelor, master, PhD, such kind of there is the order, but we cannot master minus bachelor. We cannot such kind of calculation, then that is the ordinal variable. In interval variables, we can calculate that. If the degree is 10 and we add 10 degree, then that is 20 degree. So these differences of the measurement is important for the analysis because we need to apply different method based on these kind of measurement variables. If we has for example, if we has the binary variable, then sometimes we use probit model or logit model and so on. And if we has the data ratio variable, then we can apply the OLS regression. We need to check the dataset, what is the level of the measurement, and we apply the suitable statistical method. Okay, next is measurement error. Measurement error is the discrepancy between the actual value we are trying to measure and the number we use to represent that value. This means that if they occurs at random, our sample is randomized, then it is not very problematic. But if it is not random sampling, then it is a bit it can be problematic. However, for example, the scale is consistently wrong, there will be errors in the statistical estimation. For example, the scale shows always minus 5 kg. Such kind of systematic errors happens, then the result would be biased. For example, your weight is 80%, but some kind of scales, the scale says that is 83 kilograms. The measurement error is 3 kilograms, and if the error is random, then it is statistically it is not so problematic, but always plus 3 kilograms, then that is the measurement is overestimated. Our result could be overestimated, so that is biased result. So we need to use the more accurate scales in the bathroom. Validity is here. Whether an instrument measures what it set out to measure, content validity, internal validity, ecological validity or external validity. There is two kinds of validities. Internal validity is here and external validity is here. Internal validity means the content of the test corresponds to the content of the construct. And external validity is applying to the real-world conditions. No internal validities, the conclusion would be wrong. So this is not good. Based on the result of a survey asking whether people like math, they have concluded that the people who are good at calculations, such kind of the difference between the analysis and the conclusion, that is no internal validity. This is a big problem. If you find such kind of the violations, that is a big issue. But no external validity example is here. The health effect of obesity in the United States are not necessarily the same in the Africa or Asia. For example, some kind of fruit or some kind of food is very effective for the individual health in US, but it would not be always safe for the Asian people or African people. Such kind of problem is the no external validity. But in US, it is held, then it keeps the internal validity. Next is reliability. Reliability is the ability of the measure to produce the same result under the same conditions. That is reliability. This is also very important. Test, retest, reliability. The ability of our measure to produce consistent result when the same entities are tested at two different points in time. Validity is a necessary but not sufficient condition of the measure. Second consideration is reliability, which is the ability of the measure to produce the same result under the same conditions. Testing multiple times with the same group or other random picked up group would be better if we show the reliability. Type of research data is here. Correlational research, cross-sectional research, experimental research. Correlational research is here, observing what naturally goes on in the world without directly interfering with it. This is correlational research. Cross-sectional research is the data come from people at different age points with different people representing each age point. And finally, experimental research is one or more variables is systematically manipulated to see their effect on an outcome variable. Statement can be made about cause and effect. Today's academic research, many research use the experimental dataset and can be categorized experimental research. Many research are manipulated to see the effect. And the cause and effect, causality is the main issues in many topics. Not only in natural science, in economics, there are many experiments that involve offering some kind of subsidy. For example, this is for example. But there are many experiments also in the social science. And experimental research method is here. Cause and effect is here. Cause and effect must occur close together in time. The cause must occur before an effect does, and the effect should never occur without the presence of cause. This is the basic rule of cause and effect. And there is the confounding variables. And this is mainly discussed in IPADS or the econometrics class. This is a very big issue in econometrics or causal inference, because there is the confounding variable, then the correlation is not causality. In many cases, correlation is not causality, and in many cases, confounding variables is there are confounding variables, and it is not easy to say that there is a correlation, so this is the causality. We cannot say that. the relationship between education and income is confounded by ability. This is one example. People who are smart to begin with are highly educated, so the income is not high income is not come from the higher education, but also the ability. That is a confounding. We need to eliminate the confoundings. This is an important point. For example, we can use the uncover method to remove the bias of these variables. In this case, we need to eliminate the ability effect. Then ability and other confounding variables. Then we firstly check the relationship between education and income. Next is the method of data collection between group and repeated measure. Between group is different entities, and repeated measures is same entities. There is some good point and bad point. Repeated measures, we can use the same participant, so if we use different entities, the cost is larger than the repeated measures. But in the repeated measures case, repeated sample case, the practical effect, for example, some participant learned the test or learned the questionnaires, then the answer would be different from the first time, or fatigue, they get tired in the test again and again, so the result could be changed. That is the issues of the repeated measures. For example, if you are asked about 40 pages questionnaires, this is the extreme case. You will answer yes to all of them at the end. This is not good questionnaires. We need to shorten the questionnaire as much as possible, because we always face with the fatigue of participant. Systematic variation and unsystematic variation randomization. Systematic variation is differences in performance created by a specific experimental manipulation. Unsystematic variation is not manipulated variation, age, gender, and so on. And randomization is minimize unsystematic variation. Today's development or the economics or all of the economic researches or other researches, randomization is very important. The medical science also, basically the doctors use the randomization method, I think. Then we eliminate the confoundings, because some participant had to say if someone used the medicine by some intention, with some intention. For example, the younger participant wants to use some kind of medicine, then the age and the use of the medicine is correlated. Then we cannot assess the true effect of the medicine and the result, the outcome of the hearing. So we need to randomize the participant. Finally, the research process. Sorry, could I check the slide? Okay, about 50 minutes. About 50 minutes to the end. The histogram and distribution. I would like to explain about this. The frequency of distributions. Histogram is here. And there is normal distribution, bell-shaped curve, and the most historic and fundamental, most important distribution is the normal distribution. Symmetrical around the center. This is the normal distribution. And I will explain why the normal distribution is important. And we know the characteristics of the normal distribution. The 6, 8, this within the -1 standard deviation to +1 standard deviation, the sample should be, the amount of sample should be the about 68%, and 2 standard deviation, -2 standard deviation to +2 standard deviation, then the amount of sample, proportion of sample would be the 95%. We know such kind of characteristics of normal distributions. This is a very important fact. And we sometimes or usually face with such kind of the not normal but a bit strange shape of the distribution. For example, positive skewness and kurtosis. This is a positive skew and this is a negative skew. Kurtosis is here. We call the here and here as tail. Small tail or large tail. Sorry. Light tail and heavy tail. Heavy tails distribution. There is a heavy tail distribution. This is the light tail distribution. This is the positively skewed. So the tail is long in positive values. In the negative case, this is here the tail is long. Skewness is kurtosis is also, we need to check the skewness is okay or kurtosis is okay. And this is the explanation about the word in distribution. Mode, bimodal, multimodal. Mode is the here. The most frequent score is mode. Bimodal means having two mode. In this case, this is a bimodal distribution. Multimodal means having several mode. We sometimes see the bimodal distributions. For example, the years of education. Some student, for example, some student graduate. Sorry, some person graduated high school, and some people graduated from undergraduate school. Then the years of education would be like this, bimodal. And this is also the check of terms. The mean is here. This is the median. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The order is the middle score when scores are ordered. Then this is the median. And the mean is the average. So we need to calculate the 22 plus 40 plus blah 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 and multiply by sample size. Then we can get the mean. This 96.64 is mean, and this is the median. Sorry, the dispersion. Next, we explain the range. The range, the smallest score subtracted from the largest. That is the range. In this case, this is the largest, and this is the smallest. And range is 252 minus 22 equals 230. This is the range. And sometimes this is very vulnerable by the outliers. 252 is twice as big as the secondary largest value, but the range is use only biggest and smallest. So range is 230. And another range is the interquartile range. The quantile is 25%. Using same series of values, lower quantile is here and upper quantile is here. We separate the 4 categories. Median is here. This is half. This median equals second quantile. In this case, 98. 98 is median. And upper quantile is 116. Lower quantile is 53. This is more this is more strong for the outliers than range. Range is vulnerable for the outliers, but we can ignore the very large number if we use the upper quantile and lower quantile. So this is more sometimes this is more better statistics. And I would like to explain the z-score, property of z-score. Okay. We can calculate z-score like this. Value minus mean, the value's mean, and divided by standard deviations. This is the z-score. Sorry. Then the standardizing a score with respect to the other scores in the group expresses a score in terms of how many standard deviations it is away from the mean. The distribution of these scores has a mean of 0 and SD equals 1. So we use the V minus average and divided by standard deviation. Then the mean is 0 and the variance equals 1. To center the data around 0, we can take each scores and subtract from it the mean of all scores. And this is the properties of these scores. This is the standard normal distribution. I said the normal distribution is very important. This is why the standard normal distribution or normal distribution is important. We can calculate the z-score with some assumptions, and using z-scores we test the hypothesis using standard normal distributions. The score should be distributed like this. So we assume that the most of the z-score should be within, for example, the z-score -2 plus -2 plus 2. The 95% of distribution should be here between -2 to +2. So if out of this area, then that could be different. That would be different from the other data set. Z-score 1.96 cut off the top 2.5 of the distribution, minus 1.96 cuts off the bottom 2.5% of the distribution. 95% of the score lie between minus 1.96 and 1.96. So sorry, where is, I can't see the, where is my pencil? Here. Okay. This is the almost 95% distribution. So if this is the basic rule, but in many cases, statistically different. Also, these areas are also statistically. At 5% significant level. 5% significant level. We can say that because the most sample 95% should be within here, but the value is outside of this area, outside of this area, then we think that there is differences between the, for example, the test data and the other data. If we want to say the 1% significant level, then the width would be larger than 5% significant level. I want to use the pencil. This is the この辺。maybe around here, the 1% level. 1% level. So we use the standard normal distribution and the scores. If we want to show that there is differences, statistical differences, we firstly, it is difficult. There is a not in non-parametric case we do not use these distributions, but parametric test, t-test or z-test or some other method, we assume these distributions and check the scores, and we say there is a statistical differences between the old medicine and new medicine, like that. Type of hypothesis. Null hypothesis, there is no effect. The alternative hypothesis is there is the effect. For example, the null hypothesis is the Big Brother contestants and members will not differ. This is the null hypothesis. Big Brother contestant and others, there is the differences, that is the alternative hypothesis. And we check the null hypothesis, there is no effect. If there is no effect, the contestant and other members, contestants and others, there is no difference. So the difference is within here, 95%. But the difference is out of this area, then there is a 5% level significant, the statistically significant differences. Then we can say that there is a differences or not. That is the contents of chapter 1. Okay, I stop here. Thank you very much for listening.